Factorizing is lovely when it works, but plenty of quadratics just won't split into neat factors. So here's the hero of this chapter, one formula that solves every quadratic equation, no matter how ugly, and a single number, the discriminant, that tells you how many roots there are before you solve a thing. Let's unlock both. 2 tools today. First, the quadratic formula, plug in A, B, and C, and out come the roots. Then the discriminant, the piece of that formula under the square root, which decides whether you get 2 roots, 1 or none. We'll use both on real examples. Here it is, the quadratic formula. For any equation of x squared plus bx plus c equals 0, the roots are x equals minus b plus or minus the square root of b squared minus 4ac, all over 2a. That plus or minus is doing a lot of work. It gives you both roots at once, one with the plus, one with the minus. Memorize this. It's the master key. Let's drive it. Solve x squared plus 7x minus 60 equals 0. Read off the coefficients. A is 1, B is 7, C is minus 60. Now the bit under the root, b squared minus 4ac. That's 7 squared, 49, minus 4 times 1 times minus 60, which is plus 240. So 49 plus 240 is 289. The square root of 289 is 17. Drop it in. X equals minus 7 plus or minus 17 over 2. With the plus, minus 7 plus 17 is 10, over 2 is 5. With the minus 7 minus 17 is minus 24, over 2 is minus 12. So the roots are 5 and minus 12. No factorizing needed. Now look again at that number under the square root. B squared minus 4 AC. It's so important it gets its own name. The discriminant, written as D. Here's the magic. You don't need to finish the formula to know what kind of roots you'll get. The sign of the discriminant tells you everything. 3 possibilities. 1. If D is greater than 0, positive, the square root is a real number, and the plus or minus gives 2 different answers. 2 distinct real roots. 2. If D equals exactly 0, the square root is 0, so plus or minus 0 changes nothing. Both roots are the same. 2 equal real roots, also called a repeated root. 3. If D is less than 0, negative, you'd need the square root of a negative number which isn't real. So there are no real roots at all. Let's classify one without solving. Take 2x squared minus 4x plus 3 equals 0. Here A is 2, B is minus 4, C is 3. The discriminant, minus 4 squared, is 16, minus 4 times 2 times 3, which is 24. So 16 minus 24 is minus 8. That's negative. D less than 0. So this equation has no real roots. We knew it in one line without solving. Okay, quick problem to test yourself. It's on screen. You'll get 10 seconds. Pause if you need longer. Compute the discriminant. A is 1, B is minus 6, C is 9, D is minus 6 squared, 36, minus 4 times 1 times 9, which is 36. So 36 minus 36 is 0. D equals 0 means 2 equal real roots. That's option B. Your challenge. It's on screen. Pause, find the discriminant, and drop your answer in the comments. I read every single one. And that's the whole chapter. You can spot a quadratic, build one, factorize it, solve any of them with the formula, and read the discriminant to know the nature of the roots in a single line. That's the complete toolkit. If Clarix made this click, follow along. We're doing the whole syllabus, chapter by chapter. See you in the next one.